You deploy your Angular app Friday evening. Monday morning, your users see nothing but a white screen and NullInjectorError with question marks instead of service names in the console. This Stack Overflow question has 486,000 views. It's the most common Angular error, and it costs developers 2 to 8 hours per incident according to Reddit threads. By the end, you'll know exactly why this happens, the 5 root causes senior devs miss most, and a DevTools technique that makes any dependency injection error transparent in 5 seconds. Here's what makes dependency injection errors so brutal. They pass TypeScript compilation, they pass unit tests, they even work in development mode. Then they silently crash in production when a user hits a specific route or feature. The Angular compiler can't warn you because the error only exists at runtime when the injector tries to resolve dependencies. There are 5 root causes, and the 5th one is the one senior developers miss most. Plus, stick around because I'll show you a DevTools Injector Tree technique that catches this in 5 seconds flat. Root cause number 1, the missing decorator. Your service code looks completely correct, TypeScript compiles. The service has methods, properties, everything you'd expect, but you forgot one word, the @injectable decorator. Angular's dependency injection system requires this metadata at runtime. Without it, the service exists as a class, but Angular's injector has no idea how to instantiate it. The error message doesn't help, it just says can't resolve parameters or shows question marks instead of the service name. But here's what most developers miss: circular dependencies. Service A injects service B injects service C injects service A. Angular tries to instantiate them but can't because each one depends on the next, forming an infinite loop. The error message is useless. It shows question marks instead of service names because Angular's injector gave up mid-resolution. This doesn't just break one feature. It crashes the entire module that declares these services. Root cause number 3 gets even worse: scope mismatch. Angular has 3 injector scopes: root, component, and lazy module. You provide a service with provided in root, but then you also add it to the provider's array of a component. Now you have 2 instances, one singleton for the app, one unique to that component tree. Data doesn't sync between them. The user updates their profile in one component, and the other component still shows old data. There's a 4th scope most developers don't know exists, and I'll reveal that in a moment. Remember that 4th scope I mentioned? Standalone components. They use a completely different injector configuration. Your old NgModel imports don't work. If you bootstrap application and forget provide HTTP client, every HTTP request throws NullInjectorError. The fix is one line, but the documentation doesn't make this clear. You need provide HTTP client with interceptors if you're using functional interceptors. Miss that and your auth interceptor never runs. Users see data they shouldn't have access to. And the 5th root cause, the one that trips up senior developers: lazy loaded module isolation. You provide a service in the provider's array of a lazy module. That service is only available within that module's scope. If you try to inject it into a component outside the lazy module, you get NullInjectorError. This catches developers who migrate from eager to lazy loading. The service worked fine when everything was in app module. Then you lazy load the feature for performance, and suddenly the service is unreachable. Here's the pattern that prevents all 5 of these issues. InjectionToken with a factory function. This gives you type safety without runtime class dependencies, tree shaking because Angular can statically analyze it, and 0 circular dependency risk because the factory runs after all services are registered. You can inject other services using the inject function inside the factory. This is the recommended approach from the Angular team's RFC. Most developers still use class-based tokens and hit circular dependency walls. If you're using ForwardRef to solve circular dependencies, you're masking the problem. ForwardRef is a workaround that delays type resolution, but the circular dependency still exists. It breaks tree shaking. It adds runtime overhead, and it makes your code impossible to reason about 6 months later when you need to refactor. The correct fix is to restructure your services so the dependency only goes one direction. Or use the InjectionToken factory pattern I just showed you. Here's one that surprises even senior developers. You create an interface for your service abstraction, then try to use it as an injection token. TypeScript compiles fine, but at runtime, Angular throws no provider for object because interfaces don't exist in JavaScript, they're erased during compilation. You need an injection token or an abstract class. This is the 2nd most upvoted Angular question on Stack Overflow with 124,000 views. Every single developer hits this once. And here's a bonus gotcha that generates the exact same NG0201 error. Forgetting forms module for NgModel. You add two-way binding to an input, and Angular throws NullInjectorError for NG control. This is NG0201 instead of the typical NullInjectorError code. Same root cause, different error. The reason is NgModel requires 67 internal dependencies that Forms module provides. Most developers assume NgModel is built in. It's not. Import Forms module or use reactive forms with form control name instead. Earlier I said I'd show you a DevTools trick. Here it is. Install the Angular DevTools extension. Open the Injector tab. This is the hidden gem most developers never click. When you get NullInjectorError, search for your service name in the tree. If it's not there, it's not provided anywhere. Then check the resolution path, click any service to see exactly which injector provides it. Finally, look for scope conflicts. A service in multiple nodes means duplicate instances and data sync bugs. 5 steps, 5 seconds. That's how you go from console log chaos to visual clarity. Here's what it looks like in practice. You'll see a visual tree of every injector scope in your app, from the root injector down to individual component injectors. Each node shows what providers are registered at that level. Click on any component like app component here and you see its full provider list. Auth service API config logger service. Every dependency resolved from that scope is visible. If a service appears in multiple places, you've found your scope conflict. This is the tool that turns dependency injection guesswork into certainty. If NullInjectorError has ever cost you hours of debugging, you're not alone, and now you know the 5 root causes and the DevTools technique that exposes them instantly. If this saved you time, a thumbs up tells YouTube to show this to more developers who are stuck with the same error right now. Subscribe for weekly Angular debugging deep dives like this one. I break down the errors that production apps actually hit. And drop a comment with the toughest dependency injection error you've faced. Thanks for watching. Build, ship, scale.